In this video, we're going to look at what happens to the y equals 2x. Now, we could have y equals 3x, but basically any exponent graph when we do our transformations to it. Now, you should have already looked at some transformations before, but the first one is, what if we have a negative in front of the x? So if you can remember what this does before, this turned my y equals 2x into a reflection in the y-axis, or the line x equals 0. And that's exactly what happened when we put a minus in front of the function, in front of the x in a function. We can also put a minus in front of the whole function. So this is the equivalent of y, or negative fx. And that gives me a reflection down here in the x-axis, or y equals 0. Now, if we add 3 on just to the x, then what that does is it transforms this graph, or it moves it, translates it 3 spaces back this way. So we move from here at 1, 2, hopefully 1, 2, yeah, just about 1, 2, here at 1, 2 to minus 2 here. So it's moved it 3 spaces that way. So any point where you're here and it's moved it 3 spaces. If we take the whole function, 2x, and take away 3, what that does, and this is an interesting one, it takes it down 3 places. Now, one of the things that's quite interesting there is that it's heading towards this thing called an asymptote. So that's minus 3. So if I just add one more, which is y equals negative 3, that's the asymptote that the graph is now heading towards. What if I multiply my graph by 3? Well, this dilates it vertically by 3 places. So what it's doing is it's moving it up, or multiplying by 3. What if we multiply just the x? Then that is just moving the x 3 places across this way. So we could go from here, and then we end up here. What's interesting is it's 2 to the power of 3. So it's actually doing something here with the horizontal one. So we have all of these different transformations, reflections, translations, and dilations that work in exactly the same way as we did with other graphs.